Hello, grade 9s. Today we're going to be looking at dividing a polynomial by a monomial. First, we're going to refer back to the exponent laws that we learned in Unit 2. We're looking particularly at the second law, the exponent law dealing with quotients. When I have a numerator and a denominator, and they both have the same integral base, the exponent on the top, or the exponent of the numerator, and the exponent of the denominator can be subtracted. So let's look at that as an example. 2 to the power of 3 divided by 2 to the power of 2. When I rewrite that in long form, 2 to the power of 3 means that I have 2 times 2 times 2. 2 squared is simply 2 of the 2's. I can then cancel a 2 off the top and a 2 off the bottom, a 2 off the numerator, a 2 off the denominator. Once I've canceled those, I only have one single 2 left in the numerator. The short version of this is that knowing the exponent 3 and the exponent 2 are going to be subtracted. 3 take away 2 is 1, so our final answer is 2 to the power of 1, and we don't need to write down the 1 in our power. Let's apply that into some polynomials. We're going to start with dividing by a constant. Step 1, we're going to rewrite this as a fraction. So 16x squared minus 4x plus 8 all divided by 4. Then we're going to take that fraction and we're going to distribute the denominator and create a bunch of mini fractions. So this 4 is being divided into this first term, this second term, and this third term. And it looks like this. 16x squared divided by 4, negative 4x divided by 4, positive 8 divided by 4. We're going to use the knowledge of exponent law and we're going to reduce these fractions. Looking at the first term, 16 and 4 can be reduced down to just 4. 16 divided by 4 is 4. X squared is not affected at all because there's no x in the denominator. Second term, negative 4 divided by 4. I can type that in as division, or I can type that in as a fraction and reduce using my calculator. So negative 4 divided by 4 would become negative 1. Let's look at how this is starting to develop. Our 16 over our 4 has been represented as just plain 4. Our negative 4 over top of 4 is negative 1. And this final fraction, or this final term, looks like something we've been working at since we were in grade 5 or 6. 8 divided by 4 is simply 2. Our last step is that we're going to rewrite this polynomial. 4x squared, because we have 4 and we have x squared left, minus 1x plus the 2. Let's look at another example. 3x squared plus 2x divided by x. This time we're dividing by a variable. First step is the same. We're going to rewrite it as a fraction. Second step is the same. We're going to distribute the denominator and create a bunch of mini fractions. The numerator has 2 terms, so we're going to wind up with 2 mini fractions, both with the same denominator. Now we're going to use our knowledge of exponent law and reduce these fractions. In the numerator, 3 divided by, well, it would be a 1 because there is no coefficient to x. 3 divided by 1 stays 3, so really nothing happens with our coefficient. X squared, just like I showed you in the first slide, is going to be reduced by x. 2, take away the 1 on the bottom, and we can cancel the 2 and reduce it down to 1. The bottom is gone. Looking at the second term, the 2 is unchanged because there is no coefficient in the denominator. However, there's an x on top and an x on bottom, and they cancel each other out. Last step, we're going to rewrite this polynomial. We have 3x left in the first term, and we simply have 2 left in our second term. Let's look at a more complicated one. We're going to be dividing by both a variable and by a coefficient. Rewrite it as a fraction. Then take that fraction and distribute the denominator so we can create 3 mini fractions. Now we're going to be looking at each mini fraction. We consider the coefficients just like we would a fraction, as we have in other units. Then we're going to consider the variables the way we have in exponent law. So we're going to reduce that. The negative 15 and the 5 reduce or are divided down to negative 3. 2 x's on top, 1 x on the bottom. I take 1 off of the top, which leaves me with x to the power of 1, and the x on the bottom is gone. In my second term, negative 25 over 5 becomes negative 5, and both x's, because there's only one on the top and one on the bottom, are gone. In our last one, 30 divided by 5 is 6, so negative 30 over 5 is negative 6. Both of the x's are gone. Last step, we're going to rewrite the polynomial. Negative 3x minus 5y, don't forget that y, minus 6. Some of you will ask me, can I put negative 3x plus negative 5 plus negative 6? And the answer is yes, it has the same value. Today you're going to complete a division worksheet working with this as well as some terminology using the words terms, coefficients, constants, degrees, and variables, as well as doing some division. If you finish this task before the bell, please mark your worksheet, put your name on it, and make sure it's handed in. This is due by your next class.